Hi everyone, so today we're going to learn the reciprocal function. Now the reciprocal function is basically f of x equals 1 over x where x cannot equal 0. Now in the past you've probably dealt with the direct variation, which is y equals kx, where if x increases then y increases, so in that case y changes directly with x. However, the reciprocal function is more like the inverse variation where y equals k over x. So in this case, y changes inversely with x. So if x increases and y decreases, then y decreases, and vice versa. Now, since these two are essentially the same thing, when trying to graph a reciprocal function, you can think of it as graphing a inverse variation. So, we can start off with the example y equals 6 over x, and of course x cannot equal 0. Now I'm just going to move this up a bit just to make space. So when trying to graph an inverse variation, you can first think of it as a table. So you can start off with an x and y table, and you can give random values. So if x is -3, then y is -2. If x is -2, y is -3. If x is -1, then y is -6. And then you can start realizing that it'll start flipping on itself. So if x is 1, then y is 6. And if x is 2, y is 3. And if x is 3, y is 2. And you can see that the negative signs just swap. Now you can try and graph this by yourself by pausing the video and using this table and extending the numbers on either side. But I'm just going to show you a basic sketch of how the graph of an inverse variation would typically look like. And please excuse my terrible drawing. So you can start off with one side, so you can plot the points, and after you plot the points, you'll notice that it looks something like that on either side in quadrants 1 and 2. 1 and 3, excuse me. This is quadrant 1 and this is quadrant 3. So you can notice that the y-axis is a vertical asymptote and the x-axis is a horizontal asymptote, meaning these lines, the red lines, will never touch the axes. And each of these red lines is called a branch. Now, in an inverse variation or a reciprocal function graph, you'll always have two branches reflecting each other. And another part to consider is, what if it was y equals -6x, 6 over x? And in this case, what you're basically doing is flipping your branches. So this would look like that. You're just flipping the branches over the axes. And of course, they will never touch the x or y axis. And so, if you want, you can think of it as you're going from quadrant 1 over to quadrant 2, and you're going from quadrant 3 over to quadrant 4. And so the blue line shows the negative version of our function. Now this essentially leads us to the reciprocal function family. Now I'm just going to delete everything off this page, and the reciprocal function family starts off with the parent function, which is y equals 1 over x, where x cannot equal 0. And then this leads to y equals a over x. And now this is important because this is what allows the graph to stretch or shrink. So if the absolute value of a is greater than 1, then the graph will stretch. And if the absolute value of a is less than 1, then the graph will shrink. And that means the branch will either become slimmer or thinner, slimmer or fatter. So that's stretch and shrink. And the last one is a translation vertically and horizontally. And so this would look something like this. Y equals 1 over x minus h plus k. And this may look a little daunting, but all this says is that h will move the graph horizontally and k will move the graph vertically. And so you can ultimately combine this entire thing to form one equation, which looks like this. Y equals a over x minus h plus k. And just to show you, each variable represents a means that the graph will stretch or shrink. H will move the graph along the x-axis, and k will move the graph along the y-axis. Now you can pause this video and copy this down. Now in order to fully comprehend this equation, let's use an example. So let's start off with y equals 1 over x minus 2 minus 3. And let's look at the different translations and changes this graph is going to go through. So you have a equals 1. So the stretch and shrink, nothing will happen in those terms. It'll be the same. Your h is 2, and your k is negative 3. The hardest part about translating is sometimes dealing with the h part. You see that it's a negative 2 right here. You see it's negative 2. But negative 2 actually means you're going left. Since the original equation says x minus h, that means this is a positive 2, you're going left. If it was a positive x plus 2, then you would be going that way. But since you're going, so I'm just going to erase that. Since it says negative 2, you're going to go to the left 2. So if you were going to add the vertical part, you're going down. Since it's negative, you're going down 3. And so our graph will have no change in terms of size, but it will go to the left 2 and down 3. So since I want you to completely, fully see how this graph would look like, I just brought up a picture, and I'll rewrite the equation. Y equals 1 over x minus 2 minus 3. And you can see how the graph did not change in terms of size since a is 1, but it did go over 2 and it went down 3. Now I'm going to leave all of you with a example that you can try on your own. And this example is y equals negative 1 over x plus 7 minus 3. And just for a couple hints, remember that a in this case is negative 1, h is now negative 7, and k is negative 3. And why is it negative 7? Well, since the original equation is x minus h, you're basically saying x minus a minus 7, which is essentially x plus 7. And so that is why it's negative 7.